In the previous video, we did the movement for the pawn. Now, we saw this working, everything is fine. We need now, of course, to do the same logic for the other pieces. But before we do them, I just want to show you that the pawns are the only pieces which moves in one direction. So they only move forward. All the other pieces, the rook, the knights, bishops, king, and the queen, they move in different directions. They can go up and down the board. This means that this validation that we did according to the color of the player, it's not necessary in any of the other pieces, because a black rook can go down the board and up the board. The same goes for the white rook, which can go up the board and down the board. All the other pieces behave exactly the same. They don't go forward all the time. Because of that, the possibilities don't depend on the color of the player. All of that being said, let's create some ifs here for the other pieces. I'm going to add then. Let's start with the rook and go from left to right. Then we have the knight, the bishop, the queen, and the king. That's our 5 missing pieces. Let's add them one by one. Let's even also add here a bit of space between the ifs. And let's think about how a rook moves. A rook can move vertically or horizontally. That is, it can move across the rows, keeping the same column, and can move across columns, keeping the same row. So one valid move for the rook would be something around this. That's just one example. Row, we keep the same row, and the column will be the column plus 1. So this means that we keep this same row here, but we move it to this different column. No, sorry, keep this row here in different column. So it comes to B. This is fine. This works well, but now we need, of course, to allow to move in all the different columns and all the different rows, keeping the same column. For that, we create simply a 4, y is smaller than 8, which is the size of our board. If you want to allow for a crazy chess game with the board is not 8, the size is not 8 by 8, you want to allow it to have no 16 by 16 or whatever, a crazy chess games, you can use this as a constant, bringing it from a square board size or anything. But for our case, this 8 serves perfectly the purpose. We're just going to keep it here. And now what we're going to say is that the rook can move to the same row while the column is I. So for all the columns into this row. And here we have the rook moving to all the other columns into this first row. For the other position, now we have here row being I and column being the same. So now to move in the same column across all the rows, as we see here. Of course, this rook is completely blocked to not move at all, but we mentioned already that we're only giving the movement to the pieces as they would be able to go if known pieces are there. We're not considering these blocking pieces in front or on the side of them. So for now, this is what we need for the rook. We have here this column, all the rows of this column, all the columns of this row. We do have a problem, however, because we are allowing, with the code we have here, to the rook go to the same square that it is right now. Because at some moment, this rook here is on the row 0, column 0. So the first time this adds, we're adding valid moves dot push row equals 0 and column 0. So we're just going to make a differentiate here and say if column different from I, then we add this and the same for the second row, but now for the row. And although this doesn't change anything on our board per se, there is 2 less movement, valid moves, that were removed here now from these valid moves and returned. So a bit cleaner, and also making sure that the moves that reach there are really the correct moves. And this is how it works for the rook. This is the movement of the rook. Now let's go for the knight. The knight is a bit more interesting case because it moves in L's, right? So it goes 2 rows up or down, and then 1 column to the left or to the right. So 2 up, 1 left, 2 up, 1 right, 2 down, 1 left, 2 down, 1 right. Or even the other way, then 2 columns to the right, one up, 2 columns to the right, one row down, and 2 columns to the left, one up, 2 columns to the left, one down. You get the idea. Doesn't matter if we go 2 up, 1 right, or 1 right, 2 up. The result is the same. So the idea here is not to the movement, the how it will get there, but where it gets. So we just consider the knight when we click, it needs to be able to come to this square, to C3. That's what we want. It doesn't matter if we're coming from here or coming from here. The knight is just jumping there, okay? That doesn't matter. With this in mind, we can see that the knight has 8 possible moves. So 2 up, 1 left, 2 up, 1 right. 2 down, 1 left, 2 down, 1 right. Then for the horizontal way, the same. So we have 2 up, 2 down, to the left, 2 to the right. Oh, to the left, and 2 to the right. How do we implement this here then in our movements? It's as simple as push row. It will be row plus 2, and now column will be column plus 1. So increase 2 rows and increase 1 column. This makes the L movement. Now we can increase 2 rows and decrease 1 column. So we increase 2 rows, increase 1 column. Here we have both of them there. We do the same for the other way around. So now we have row minus 2. And to the horizontal movement as well. The row will be 1, we're changing 1 for the row, and 2 for the columns. These are the 8 possible moves for the knight. Of course, 5 of these movements, they are out of the board, so we don't show them, but these are the 8 possible moves that the knight can have. And to make sure that, just like we did with the rook, that we only give the correct valid moves into our array and not the ones that don't make any sense, for example, the other 5 which are out of the boundaries of our board because they have negative rows or columns in this case, or maybe even bigger than 8 on this case, we're going to make some ifs here. At least this is the first idea we'd have, right? We can say row plus 2, it's smaller than 8, and row bigger than 0, and blah, 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 and blah, blah, blah. We could add a lot of ifs here, but if you look at it, this is going to be very complex. We're going to make one, or actually even more than one validation for each and every move of that we want to do. As we have 8 moves, this will cause us, I think, 12 ifs to be added here in this code. And ifs add complexity to the code, and we don't want our code to be complex. So we want to remove complexity here. And fortunately for us, there is a much cleaner way of doing this. What I'm going to do here, it's a temp moves. This temp moves, it will be an array of coordinate model. A simple array, which I'm going to use, as you can see, temp, so temporary, before we insert everything into the valid moves. So instead of saying here valid moves, I'm going to replace all of these by temp moves. And now the valid moves, I'm going to push these temp moves, but filtered. So now we filter them out. And how do we filter? We say if move.row it's bigger or equal than 0, and move.row it's smaller than 8, or smaller equals than 7, whatever you prefer. And we do the same for the column. So we make sure that the moves that we added here to the step moves are indeed valid moves, like so. And now our valid moves will be inserted just the 3 moves that this knight is allowed to do. This is then the technique of using a temporary array to store all of the other ones and thus filtering out. This works because the rule for all the moves to be valid, it's always the same. If this have different rules for each and every case, this would never work. So you need to create ifs and more ifs, or at least use some other patterns. But in this case, we can do this simple adjustment and makes our code much cleaner, much easier to understand, and of course, to maintain. We can now move on to the bishop, and the bishop moves in diagonals. So there's 4 diagonals the bishop can move: top left, top right, bottom right, bottom left. For each of these diagonals, it's quite simple, the pattern where it moves. it will, whenever it's going to the top, it's increasing the row. Whenever it's going to down, it's decreasing the row, just like the rook. And now, whenever it's going to the right, it's increasing the column, going to the left, decreasing the column. So technically, the bishop, if it just could move just one square, it would have these moves. Push, row, it would be row plus 1, and column to be column plus 1. I'm going to add then here column minus 1, and the same, but now down. So here minus, minus. This is the movement the bishop can do if he could only move one square. But as we know, the bishop can move up to 8 squares, like the whole diagonal if he can, if he had space. So we create a for that I equals 0, smaller than 8, I plus plus. Bring all of this inside, and we're going to replace all of these ones for i's. Here and here. Okay, now our bishop can move in all these directions. Up to there, up to here, and of course below, but there's no space to go with below. It's under the boundaries. And just like we did with the knight, we need to verify if these moves are valid indeed, if it's inside the boundaries of the board. What we're going to do, the same technique. I'm going to replace these valid moves by temp moves, and our logic remains exactly the same for the board, but now cleaned up of all the moves that don't make any sense because they are out of the boundaries of the board. Now, I see a pattern happening here. These temp moves and valid moves with the filter, they're happening in two places. So instead of repeating this code for both type of pieces, isn't it better for us to just get all of this filter and bring to the return? And instead of using a temporary array, like we did before, we can use the valid moves that we had before, like so. I'm going to replace here, replace all. And now our code is even simpler. We specify inside each of the ifs what are the possible moves for this kind of pieces. And then in the end, before we return everything, we strip out all of the moves that are not allowed for this piece. And this is even interesting because as of now in our pawns, we could allow the pawns to also go off the board. With this being brought to the return of the method of this function, this doesn't happen anymore. Now the pawns will stay within the boundaries of the board. What didn't change though, it was for the rook, because the rook, we always did the check already here that everything is the way it is. But the rook makes this validation. Could this validation be brought here instead of checking here the rook? And then we make sure that we always check if the piece is not moving into the same square that the piece is already. We could bring this here. Does it change much to here or here? No, not much. But I'd like to put it there to keep the consistency. Okay, so I'm going to remove this from here. And in the end, I'm going to add another here check, which will be end. And inside of it, don't forget the parentheses because it's a double check. We're going to see if the move.row is different than row or move.column is different than column. So one of the coordinates needs to be different. Otherwise, it means that it's the same square that the piece already is. Let's come back to our code, to our board, and see if everything is working as expected. Here we have all of the working exactly as before. So our code here, filtering, is working perfectly. Which brings us to the queen. What is a queen in terms of movement? A queen is a bishop and a rook. So instead of doing this extra if, we're just going to add a new specification here through the logic we already had. And now, I forgot there's an empty here. Let me remove this. And now if I select the queen, here's all the movement. Because the queen is exactly a bishop plus a rook. As long as these two logics are correct, we can add it to the queen and everything is fine. Everything is perfect. The king, though, it's a queen, but very limited. So the queen is the same logic that we have here for the rook and for the bishop, but with only one square which can go. As it doesn't make sense to create a 4 just going from 0 to 0 or 1 to 1, we're going to add the movements directly. Which are these movements then? These movements will be row being row plus 1 and column keeping the same, just like here, the rook. I started there with the row, so let me invert here. So I'm going to say start with the row, and column is column plus 1, column plus 1. This is the first two movements. We also need them in the other direction. So I'm going to say that row is the same, column minus 1, and here now keeps the same column, but row minus 1. This makes our king be able to go to the horizontal and vertical. Now we need to allow our king to go to the diagonals. There is the bishop. The moves will be then, let me copy paste this, to be slightly easier. Row plus 1, column plus 1. Now row minus 1, column plus 1, row plus 1, column minus 1, and row minus 1, column minus 1. And now it can go to all of the 8 directions. 8 movements, just like the knight, 8 possible moves, but specific, just like a queen, with the limitation of just moving one square at a time. And this is the movement of all of our pieces. It's as simple as that. If you break it down in smaller pieces and try to understand how each piece moves and then how to translate this into code, things are not that complicated. You see that the code we have here, it's quite simple and quite understandable. You can add some comments if you'd like to. I don't think it's necessary, but if you would like to, it's your application. Please go ahead. Of course, we still didn't deal with the problem that our pieces can capture our own pieces, capture pieces all across the board, can jump over the other pieces and so on, but we're going to deal with that later. What I want to do now is to allow our pieces to move, no matter where. So if I have here this pawn, I want to be able to move the d2 pawn into d4. That's what I want to do. When I select this, I can go to here. Or if I select a knight, I can come here. Not worrying about too much about getting over the other pieces, okay? We're going to deal with that later. It's going to add complexity, but for now, I just want to move our pieces and then we can deal with that logic because everything will come together in the end. To do this logic of moving the pieces, we need to come to our board. Let me close everything we have. And now our board will have these squares. These squares have a select function, which as of now just set the selected square. But select may also be confirming the move. And here we have then two options. Or we send down a function called move, let's say, to the square, and the square itself will have the responsibility of knowing when it should move and when it should select this piece. The second alternative is to have just one function in the square, and the board itself knows what is the difference between moving and selecting. Here's then its personal decision, a product decision to know where the logic should be. Should it be on the board? Should it be on the square? For me, it makes more sense, but that's my personal vision, that the board knows how to deal with that than the square. For me, I'd like to keep the square as simple as possible and just say, I was selected. The user clicked on me. Deal with it. Do whatever you need to do. And then the board is controlling the game. Actually, the app is controlling the game. We may need to bring this logic even up here, because here we have the player turn, the board, and maybe even some more stuff that will come up. So we need to understand where the logic will be placed, but as of now, the best place I can see is the board. And in React, whenever things start getting like with siblings and all, we move the state up. So we're going to maybe to use this technique to move the state up at some point and bring it to the app. And I most likely think we will. But as of now, the board is the best place to do it. So let's get to it. First, remove this move function here. We're not going to need it. And this select, I'm going to create a new function, which will be select square. I'm not really that fan of this name, but we're going to get there. We change later on. Square model and this selected square. For now, we'll just set the selected square of square. Simple like so. And I can pass this down here. This also actually can receive a null because it's the type there on the square the square component. And this is our first change because now in the select square, we can verify certain stuff. We can say if there is already a selected square, we can do something. Selected, no, not select square, selected square. Because that's why I don't like the name of this function. I'm trying to think of something better. If not, we're just going to select it. Okay. And now, if this is selected, we need to check if the square that we received dot coordinate dot row is the same as the selected square we already have. And the same for the column. If so, now we are dealing with what? With an unselect. So set selected square, no. Else, we're going to refactor this, okay? If else here, I don't like it. But now, if so, now I'm going to add it here, reform move. And from our square, when I have on click, we're just going to pass over this square. Because this logic is now being done in the board, so no need to do here in the square as well. And this select now don't need to send a null anymore, it will always send a square. And here we can also change this to be always a square model, it will always receive. And here then we have this validation to see if it is the selected square. The same that we do here. So we can remove this and put in a separated function, right? Const is selected square, receiving the parameter is same, let's go say is same as selected square, return a boolean, and this will receive a square model as a parameter, and do this check. Return this. Add this to here. Now, square. And also add this to here. Selected is same as selected square, sending up the square. Of this with here, organize a bit the code, and see how little by little our code is getting easier and easier to verify and validate. Here we need to check if this exists. Okay. And finally, after all these checks, validations, and refactor, we can perform our move. How do we perform the move? Changing the piece of the square. In our board model here, we have squares, an array of squares, and these squares, as we see here, have a piece which can be set. So what we need to do is to update the piece in each of the squares, in each square that matters. Let's go here then to our board model and create here update square piece be a function, just like we have it here. Return void, no need to do anything. And now, what we receive as a parameter, it can be a coordinate and a piece, or a square and a piece. I think it makes more sense to receive some coordinates. So coordinate model, and now piece, which be of piece type, if not mistaken. Let me just double check. Yes, or can be a piece type, or no. Can also reset, right? We can also remove the piece from the square. What we're going to do now here is squares. This dot squares dot find. Let's hit square and just check. Square dot coordinate dot column equals coordinate dot column, and square dot coordinates dot row equals coordinate dot row. Whenever we find this element, I'm going to set it here. I'm going to say here the square index. Actually, then I forgot here, it's not find, it's find index. We just want to find the index of this piece. And now we're going to say these dot squares in the square index. So this piece we found dot set piece, sending piece. As piece here can also be null, we need to update this in our square model. So I'm adding here, and I already see a mistake I did. Indeed, I cannot send a piece type. I need to send piece model. Which is slightly different because the piece model has also the color, which makes a lot of sense. So let's remove this import and let's just the piece model there. And this piece.piece cannot be assigned because we said that this can only be piece model. Let's also add this as a possible no. And we can initialize it by default as no to remove this small problem we had here with TypeScript. This is what we have now in our board model and our square model, updating the piece in each of these squares. Now in our board component, what we're going to do is update the board. So we're going to say board dot update square piece. This square piece will be what? Of course, our first the selected square. So selected square. We're going to say no. So remove the piece from this selected square coordinates. And we're going to say from the square here, this coordinates, I'm going to say selected square dot piece. That's what we're going to do. We're sending to the new coordinate what is the piece in the selected square, and then in the selected square, we put the piece no. Coming back to our application, I'm going to refresh, remove all the errors that we had during runtime, selecting our dpon, I click here, nothing happens. Do you know what it could be? What is wrong with our code? If we look in our select square, we are updating the board, which is a prop. That's not good. That's not good because the parent component, in this case app, should be the one updating board. And because of that, whenever board updates, our board here component will be updated accordingly. So what we need to do here is to call an event, and which we'll call move piece, sending 3 parameters there. Selected square and the final square. Not 3, just 2. I thought 3, but I have just 2. I'm going to say here, selected square and a square. This move piece, of course, it will be also a prop, so move piece function with current square to be square model and final square model, which returns void. Okay, that's the type of our props. Let's get it here. Move piece, and in our app, we create the move piece function, which I'm going to create here. Const move piece, and add this code here. I'm going to have void and pop this, the type, be a bit easier for me. Current square is a selected square, and final square is here. It's this one. We add this import, add this to the models here. And now we send down the move piece to here. Simple as that. And after we move a piece, technically, we set player turn. If, going to say here then, current turn, being if current turn is player is equals to player color dot white, it becomes player color dot black, otherwise it becomes player color dot white. Now we also change the player turn whenever we make a move. Coming back to our application, I'm going to refresh, remove the errors in the console, select our pawn, and now move it here. That's, you have it. The movement, the pawn go from D2 to D4. Of course, we didn't clean up, but our pawn moved. So just to finish this up, in our board, after we move the piece, we're going to set selected square. No. Going to remove it. If we look at this logic that we have here, we can just invert this, add the move piece to here, and after all of that, we select the selected square to no. Coming back to our application, going to refresh, we click, we move, our pawn goes there. Now, if I select another pawn, here we go. Now it's white's turn, so can bring here, black's turn, white's turn, and keep on going. Like, our game is technically playable as long as you don't force too much, because now if we select the black pawn, we can go over the white one and kill. That's not how it works. But this is something for the next video.